So I had question 20 and they asked us to find which one of these is an impossible electrostatic field, and what that means is if you take the curl of an electric field and it equals 0, that means it is possible. So for the first one, the curl is not equal to 0, so it's not possible. And then the second one, we see that the curl is equal to 0, so it is an electrostatic field. So then they ask us to find the potential of this, the one that's possible, using 0 as a reference point. So using this, the easiest way that I could think of doing this was doing it in 3 different sections. So going along the x-axis, going along the y-axis, and then going up the z-axis. So for path 1, we're going to find E dot dl, and then that's just equal to 0, because y and z is equal to 0 at this point, and dy and dz is equal to 0. For path 2, z is still 0, dy and dz is 0, and y goes from 0 to y naught. And then, so E dot dl, do all of this, and then you find the integral, and then this is what I ended up with for path 2. And I did the same thing for path 3, and then I get this. So the potential is just you add all this up, and then you get this. That's our answer. And then they asked us to double check by computing the gradient of v, so I did this. And when you find the gradient of v, you know that the gradient of, let me write it, e is equal to the negative gradient of v. So I found the negative gradient of v. After all this work, we find out that it is exactly the electric field from part B. And that's kind of it.